And to put tonight's control flow topic into context, control flow refers to conditionals, if-then statements, as well as loops, specifically for loops. And you're probably all pretty familiar with the concepts already from working with things like workflow and process builder and visual workflow. Those all do a lot with conditionals, so we'll see how those get translated into Apex. And we'll also be looking at some of the less typical ways that things get written in Apex, so that if you're running across other people's code and they've chosen some of the more esoteric ways of writing Apex, you'll be able to decode those, reverse engineer it, and get it working in your own orgs. Because like debugging, that's another thing that we do a lot. And finally, we'll also be looking at the documentation. Because we also go to the documentation a lot to look at the various methods that are out there that can save us some effort in making our code work better, and also just getting familiar with how to Google for answers, because sometimes the documentation doesn't explain it as well as we'd like, and others have stepped in to give us better answers, whether it's in blogs or Stack Exchange or developer forums. There's a lot of information about Apex out there, and a lot of people willing to help you figure out exactly what's not working. All right, so with that said, I will go ahead and see if I can pick the right screen to share here.
The annual is Luke going to be successful? Everybody place their bets. We can see your screen with force.com homepage.
Excellent. All right. And I will flip over here to my developer console. Here we have our developer console with, I've already loaded the control flow Apex class here into my developer console. And all you'll need to do is copy that from the GitHub gist and copy it into your own developer console. And we'll go through this, and there'll be quite a few sections with Fix Me in them, where we'll have a chance to work with the code and run tests and see if our tests pass and if the debug logs spit out what we expect them to. And with that, let's go ahead and jump into control flow. So we're going to start with if statements. We use these all the time. You're already using these a lot in workflows, so I think that everybody kind of gets the basic behavior of an if-then statement. We have the most basic of them written here on lines 16 through 19. We always start our if statements with the word if, and then we follow that with a condition in a couple of parentheses. And that condition must result in a true or a false output. So the simplest thing you can do in there is just simply put in true or false, as I've done here. And in this case, this statement is always going to execute, because as long as whatever's in the parentheses is true, we're going to move on to what's in the curly braces here. And that's where the action happens. So in this very simple one, every time we run the test on this particular unit test class, this is always going to fire, and this system debug is always going to fire here. So everything that you do in a conditional will be between these curly braces, unless you've got something really basic. You can even condense it onto just one line. So this is an example of something you might see in others' code if they are trying to, I don't know, save on curly brace expenses and ditch them, because you can simply go right from your if conditional right into your action. This only works if it's just one line of actions. So in this case, we just have a system debug But if we wanted to do some other action in there, we would have to slap in some curly braces and start going on multiple lines. And that said, I recommend always using the curly braces. It just makes the code more readable for yourself as well as for others who follow in your footsteps. All right, so let's move on to something a little more complex because it really couldn't have gotten any simpler than that first one. So for starters, I'm going to prep a Boolean variable here. And so I start by initiating that and saying this is going to be a Boolean, and I give it a name, my bool. And I'm setting the value of that Boolean to true. And shortly we'll see that unlike checkboxes in the interface, Booleans in Apex can have true, false, or null as a possible value. So if I were to leave out any true or false there and just have that, that Boolean is going to be null and would not actually work in conditionals because it can't interpret to a true or a false. We'll get to play with that in a minute, but for now let's set that back to true and see how we play with it. So moving along here to lines 29 through 34, we've got that my bool variable in our conditional, and we have our first set of curly braces. And so whenever that first set evaluates to true, whatever is going to fire in that, whatever is written in between those curly braces will fire. But we quickly get into other conditions, and this is where Apex starts to move away from what we can do with workflow and get more similar to what we do with Process Builder or with visual workflow. We can have chains of conditions, or in the case of this else statement, we can have a sort of failover. So this first statement, if my bool is true, this is going to operate, and if it's anything else, this next section is going to operate. So with a Boolean, that just means if it's true or false. When this evaluates to false, this else phrase kicks in, and we get this next action. And then just to demonstrate where all of this ends, after the last curly brace here, we've got another system debug. This follows after the conditional and has nothing to do with the conditional. So this is where your code gets back to moving through everything regardless of whether conditionals apply or not.
So I think that it should be something that's fairly easy for, at least at this level, as far as we've gone so far, it should be very easy to understand for anybody who ever worked with complex formulas in Salesforce, where you can use your if condition and you have to provide one value if it's true and one if it's false, right? So
right, exactly. Yeah, so formulas give us that else architecture, either by using else or also using case statements. Case statements are another way to step through a variety of conditions. Mm-hmm. And we don't have the exact equivalent of case statements in Apex, but we do have something very similar, and that is our else if. So you can always follow an else with another if conditional. So in this series here, we've got first our initial condition. If my bool is true, we go into this particular line. And then if it's not true, it's going to skip to this next line and see what it says. And here it says, else if my bool is not true, and we've got our exclamation point that is the not operator, and that reverses the Boolean. And in this case, it's going to fire off a different command. Well, actually, the same command. I suppose I could have made that a little less obvious, or a little more obvious that they were different. And then we march on to our final failover condition. And this will operate regardless of any condition as long as these first two do not come out to be true. Now, if any of these come out to be true, all the rest of it is forgotten. So for our first conditional here, if my bool is true, the rest of this is never going to get considered. It'll just break out of that conditional and move on to the subsequent lines of code. So let's go ahead and run our test, and we'll take a look at what the output here is. Should save it. I think I made some change up there. So I'll go ahead and run our test. And let me make the logs a little easier to see here. All right, is that the most recent one? Yes, it is. Let's go ahead and pull that open. And we were working with, I think that was line 38, right? All right, so that's where we want to take a look for our logs. So I'll go ahead and enter 38 into my filter, and that takes me right into line 38. I'll go ahead and highlight that and unclick filter, and that'll drop me right here where I want to be. And I can look through this and see that the system debug shows up right here, and it says the Boolean was true. Now that true there is coming from a reference in the system debug that is actually pulling the value of that and dropping it into the debug output. And note that when we have a Boolean, that Apex uses the text, the string true or false, as its output, although it does not have to appear in single quotes. So if we look back up here at line 22, I just dropped in the word true, and in this case, Apex recognizes that as a Boolean, and it's a reserved word, in fact. You can't use that elsewhere. Same with false. And it does have to be outside. It cannot be contained in single quotes. If we put single quotes around that and treat it like text, we're going to get an error that says the condition expression must be of type Boolean. So what that's saying is whatever I have here in my conditional is not something that will evaluate to true or false. And in this case, it's because I had single quotes around it. So I'll go ahead and take those out. All right, so that was what happens when we had my bool set to true. But let's flip that over to false here. And if we look ahead, we can sort of analyze what's going to happen. In this first simpler block, we know that it's false, so it's going to skip this line here, and it's going to drop into that else statement. In this case, it'll spit out the Boolean was false. We look at our next block of conditionals here. Again, if my bool is true, we're going to do 38, but it's not. It's in fact false. And so here, it's going to drop false in, but with that not operator, it's going to reverse it and make the conditional true. My Boolean still remains false, but that means it's going to execute line 40. So if we run this now, when we go over to our log, this time I'll click on the debug, just another way to get in there. I can see that line 40 fired. Last time, when the Boolean variable was set to true, it was line 38 that fired, and this time it was line 40. And that's because
look, can you also put on the first log, can you also put it in debug so people can see which exact debug state? Because without the debug checkbox checked, it's hard to see which lines actually fired and which didn't.
You know what? And I can bump up my view size here now that I remember that this is a small screen, and
I think it's good size. The size wasn't an issue. Just a lot of other lines. So you can see that on this one it jumps from 34 that didn't matter to 40, and then 64. And on the other one it jumps from 34 to 38, and then 62. So in first is 38 but no 40, and in the second one 40 but not 38.
And then our first challenge for you, for everyone out there, go ahead and set no value. So we have an else condition here that says, well, if it's not true or false, it should fail over to line 42. So if it's not true or false, all that leaves us with a Boolean is just no assignment. So we're able to save that without any assignment. And I'll give everyone a second to change that and save it and run your test. And then scratch your head at, why did I not get a success status here? So what we've encountered is the fact that the conditionals really want a true or a false. They do not like null. If I click open the status, that's just taking me into my logs, but I'll see if I can find that status output there. We get this unfriendly error that says null pointer exception, attempt to dereference a null object. So this is Apex's way of telling us that it was expecting some value. It in fact demands some value, but all we gave it was null. We gave it nothing. And when it does that, it can't evaluate it one way or another. Now this is a really easy way to force this error with Booleans, but this is something you can encounter with other data types as well. Certainly if you set up conditionals that are looking for a string and there's supposed to be a string there and the value is null, you can get this error. If you're returning values from a SOQL query and you expect some value and there's no value there, you can get this error. So when you see this one, you should start looking through your code for, where is there some situation where Apex really demands a value and all I've let it do is null. A lot of times you have to code around that so that you say, if something is null, do something else than what I originally intended. We'll get to see a little more of that when we work with Apex triggers and can start really putting together some more complex flows of logic here. But this was definitely a trick fix me to demonstrate an error that is unfortunately not uncommon and one that you'll need to know how to hunt for and resolve.
Hey, Luke, I don't know if you plan to talk about that. If you do later, then just stop me. But what's interesting here in what you just did is the reason that it failed. If you go back to that log that failed, can you go back to that log and show the line that it failed on? So we can't actually see which line it failed on, but I'm sorry. If you go back to the code,
it's 29, line 29. That's right. It's right there.
Yes, you're right. I'm sorry, 29. Thank you. So what's interesting here is that in line 29 is the first time that we put the myBool inside an if statement, and the if statement, what it's looking for is something that returns a true or false. So right now we have a Boolean, and a Boolean should always have a value of true or false. Now, the way that you declared it earlier without an assignment, it actually does assign, it does create a myBool variable with a null value. But when you put it inside the if statement itself, whatever is inside that parenthesis still must return a true or false. So an actual fix for this would be to say instead of if myBool, you can use if myBool equals true in the first one. And then this while will actually evaluate. And then in line 37, again, you can say true. You can say false in that one, or not equal true, that's fine. Yeah.
I think I dropped a parenthesis.
Okay. Well, either this or this. Right now it's either not or true. Or you can, if you do the not and false, it's not going to.
Oh, yeah. Thank you.
And then it should actually get to line 42 because it's not true, it's not false, so it is null.
Thank you for demonstrating that. That is exactly
so you can actually have a null value in a Boolean. That is fine. You just cannot have something that returns a null value inside an if statement.
And I think I must have made an error here. I think if I take out that not, we should be able to get to line 42, because I didn't see line 42 come out. So I say,
yeah, instead of not, say equals false. Yeah.
Oh, there we go.
Because it was not true, it was null, so it failed that if statement. You're right.
All right, let's see if we can finally see line 42 here. Oh no, it's still not coming out. So it jumps on 38. Let's see if I can figure out why that was. All right, well, that's because I left it at true. All right. Welcome to Debugging 101. All right, let's see what happens now. Uh-oh, we're back to our attempt to dereference error.
I guess my entire lecture was false then. I was pretty sure that I've done this before.
Well, look at that. It did get to 42.
Oh, it did get there. So something else failed later.
I bet I make another reference to it. I bet if we look, let's see, where did it got to 51? Yep,
51.
we must have something. We have something else waiting far ahead of us. But I think that Ohad's lesson was actually correct. That
I thought I made myself a fool
way.
for it.
So there is a way to get around a null value, and that is by using these comparison operators here. And once we do that, it is able to evaluate my bool. It's able to say it's null, and it's able to compare it to true, and able to return and say, well, my bool is not true, therefore this statement is false. And the same thing we have here. It said it's null does not equal true, so it skipped that. Went on to the next one. It said null does not equal false, so it skipped that. And then it cascaded down here into line 42, our else statement. And this is exactly the type of solution that you end up applying when you find this in your own code, that there's conditions that can return null and that throw that null pointer exception. You have to kind of go back through your conditionals and break them down and find a way to handle that null elegantly. All right, and just to cover one other edge case of basic conditionals, we've got this oddball one here called the ternary operator. And this is a very limited use, but one that you do encounter out there because it's very convenient, but it only works when we are doing variable assignment. What does that mean? Variable assignment means that we want to set up a variable, in this case a string called the answer, and we want to set up a conditional that will give that different values. And in this case, it kind of looks a lot like something we'd see in workflow. We have initially a condition, and in this case it's simply returning to my bool, and this must be where that new null pointer exception was thrown. And following Ohad's method here, I'm going to just set that as a comparison conditional. And now we have this question mark. So that's an operator there. So that's an operator in the sense of something that the code uses as a stand-in. And in this case, it's saying whatever precedes this is the condition. Whatever follows it is going to be the output if the text output if the conditional proves to be true. And then we have a colon and we have the output if the conditional is false. So a lot like what we would see in a workflow if statement, where we have a condition, then a comma, and whatever the output is for true, and then another comma, and whatever the output is for false. Now in this case, I've used true and false, but I could also have up and down here. And then it's going to evaluate the conditional here. So now that we know my bool is currently null, we can look through this and say, well, since that is going to evaluate as null is not equal to true, therefore it's false, it's going to assign down as the variable called the answer. Go ahead and save that, and we'll see if we run it now, if we are finally past our null pointer exceptions. And we'll take a look for line 51. On my debug. Oh, what do we get? Now I didn't do a system debug. That's why we've got nothing there. All right. Let's go ahead and make that change in there, and we'll be able to see the output. Come on. There we go. My own browser is getting a little wonky here. Give it a second.
That is a time to say that the developer console sometimes can get very, very annoying. It's not very uncommon when you work with the developer console for it to freeze or
and in fact,
start being really laggy.
And when that happens, I usually just close it and reopen it, provided Chrome isn't going to just crash altogether on me here. Come on, Chrome.
Do you have any other Chrome windows open?
I might. Let's see, there's another window. I'll close that one down. Hey, now we're back in business. Okay. And it picks up where we left off. So we were here on line 51. Let's throw in a system debug so we can actually see what came out of the answer. Close some of these others here and run that. And there we have it. We can see that it evaluated the output of null equals true as false, and therefore it assigned the variable with the string down. So again, this variation with the question mark and the colon only works for variable assignment, but it is a very convenient way to do that. Otherwise, you'd have to expand that into a few lines. All right, so now we've got your first challenge here. So we're going to attempt, we're going to attempt to do the opposite. We're going to try to change a Boolean value into a string. Previously, we had set up a string here, and we took the Boolean and we converted it to true and false. Now we want to do the opposite. So what this is going to require you to do is Google Apex Boolean methods and look for the documentation and figure out from the documentation how you will set up a Boolean that evaluates my bool and populates it with the true or false from the answer. If that wasn't clear, probably easier to read what I wrote, because I think I probably thought it through a little better when writing it out. I'll give everybody a minute to work on that, and then I'll show you the answer here. So hopefully everyone found their way to the documentation here for Apex and found this Boolean class. And when we look at this, we see there are a couple of methods here. And if we read through these, we can see the first one here says, converts the specified string to a Boolean value and returns true if the specified string value is true. Otherwise, returns false. So a scenario where something like this might be useful is if you're using a pick list in your interface, and that pick list has values of true and false. In fact, that's something I often suggest that my admins do when we know that there's a field that we may not know whether the answer is true or false. So a checkbox would kind of give us a false impression of whether we know the answer to it or not. And by using a pick list, if we have selected nothing, if it's still at none, the question hasn't been answered. If it has, then we have a true or a false. But then if you need to use that pick list in Apex, you want to get that into a proper Boolean for future use. So this is a scenario where we might be doing just that. If I click this value of link, it scrolls us down to a nice set of more deep definition of what we're doing here. And it gives us a description of how we set it up. It tells us that we have to give it a string. That's the parameter. We have to feed it a string. And when we do that, it's going to return a Boolean. And then it gives us a nice example here. And if we take a look at this, we can see that here it's defining a Boolean, B, and then it's calling the Boolean class. And this is just the generic Boolean class followed with the dot notation of dot value of. And then here's the string we're feeding it. In this example, it's just feeding it a string, not a variable. However, in our code, we're going to feed it an actual variable that we've created, the one that we call the answer. Sometimes when I really want to try and figure these out, I'll actually copy the code from here by clicking on that little icon there, which is going to pop up a window that makes it really easy to cut and paste that code right into my code. And once I have it in there, I can sort of do a side-by-side and essentially reverse engineer what I found in the example. So if I look at this, I can go, all right, well, let me uncomment that and get rid of those question marks that Luke left in there. And I'm going to copy this part in because that's what's missing from mine. But then I don't want to use just a string here. I want to use the variable that we created. I'm going to use the answer. And then if I want to reverse engineer my assert equals, well, it looks like I can pretty much just copy directly what was there. Now I'm getting an angry red exclamation point here because I've left this code in place and it sees me trying to use the variable name b a second time after I already defined it. So I'm going to go ahead and get rid of that now that I've made use of it and save this. And if we run this test, hopefully, we got a failure here. Now, I know why that is, but let's take a look at that failure. You know what, I want to actually, I'm going to show this from the test tab here. Since we're using a system assert, whenever a system assert fails, it's going to give us some very specific output from that. So it's going, and here it tells us that the assertion failed. It expected true, but the actual return was false. And that's probably because we left my Boolean in a null state up here. So let's go ahead back up there and restore things to the way they were originally set. and run our test again. Hey, and now we get the friendly green check mark that everything is as we wanted it to be. So what happened there is we set up a Boolean called B, and then we used this Boolean class and method to take the text value called the answer, which from back here ended up being true, and that converted it to a Boolean. And then we test it here. We say we expect it to be true, and when we put the Boolean in, that comes back as true. So everything worked out. Okay, so moving along to more comparison operators here. We already saw previously that we could use a double equals sign. So we were doing this with that scenario where we had the Boolean set to null and using that to compare it to true or false. But we use it for a lot of other comparisons between strings, between integers. And the really important thing to remember here is when we're doing this, we're using two equal signs as opposed to one. I guarantee that you will forget that and you'll get an error. And in fact, we can even try and invoke that error right here. The compiler will catch up in a minute. Or I can hit save and force that. And it says this expression cannot be assigned. What the heck does that mean? What that means is that a single equals sign in Apex and in coding languages is an assignment operator. So if we think of what we saw with data types, if we were to create an integer, and we call that, I'll call it G, because I know I haven't used G anywhere in here, and do a single equal sign, I'm assigning the value of 4 to the integer G. But when we're doing comparisons, we're not doing assignment. We are also saying it's equals, but we're really doing a comparison. And another way to think about that or remember it is if you're doing comparisons with numbers, you use a greater or equals, or perhaps a less than or equals. So again, you're using two operators side by side. So the double equals is just the equals equivalent of greater than or equals. And of course, one that we're probably familiar with from formulas is also the not equal. So again, it's using that two operator format to designate that this is not assignment, this is comparison.
Right, and just to add on there real quick, what can happen, so the reason that we can't assign 4 to the, right, we can't assign the length of a string, right? We can only find out what that length is. It is quite possible to inadvertently put an assignment statement inside the if parentheses, and what that then means. So let's say, if you change that to if G equals 5.
Okay.
Just for laughs, right? So here, so what this is going to do is it's going to assign the value 5. My mistake here. Oh, because there's no, in some languages what can happen is,
it could only happen, I think, with Boolean.
Okay.
I think what you're trying to describe would only ever happen with Boolean because you still need to return a true or false inside the if statement. Right? So the first error we got was because you really cannot assign a value into length.
Right.
That was why the error we saw was the expression cannot be assigned. And once you change it to something else, suddenly the error changed because now it was able to evaluate what was inside the parenthesis, but it failed when it tries to evaluate it as a part of an if statement.
Right. Yeah. Sometimes assignment will work. The assignment function will return true if it succeeds and can be used as used in an if statement. But I think, yeah, I was getting confused with that. I think that doesn't happen in Apex. I apologize.
That's a good point, though. Yeah. Sorry. Go ahead.
Yeah, it definitely is, a hazard out there, and one that you will no doubt encounter pretty quickly. And another one that I'm encountering right now is I typed in length, and I get this unfriendly, unhelpful, rare message. Initial term of field expression must be a concrete S-object string. And that's really trying to tell me it doesn't know what I'm talking about here with length. And that's because I left out my parentheses. Length is a string method, and that means I have to have it properly formatted. And then I get on to the next error message, which says I was trying to use 1 equals, and I need 2 there. But now everything should be cleaned up and functioning. So in this case, we're using that string method to get the length of the number of characters in our string, the answer. Which we know to be the word true, and in this case it is 4 characters, and that means that it's going to return this particular action, telling us that it was exactly 4 characters long. But I can also then go on to an else if statement and say, if it's greater than or equal to 5, then it's going to return this longer than 5 characters. All right, so hopefully you got enough of a grasp of the comparison operators that we can start to work on a much more complex bit of lab exercise here. So I've got a long enough exercise here that I had to stop using the // comments and actually use a /* comment block to make this whole thing a comment. So you'll need to take those out, the one at the start and the one at the end, and then work through this particular exercise here. You're going to have to set up your conditionals using this string here, my pick list, which has an initial value of up, and get each of these conditionals to function so that all of the system asserts behave the way they're supposed to. So I'll give everybody a couple minutes to start working on that before we take a look at the answer.
So look, I do want to make a point to kind of highlight what Thomas was talking about earlier. And what he was saying is absolutely correct, but only if you have a Boolean inside of your statement. So if your statement is if, my bool equals false, you're actually assigning the value false to bool while you're evaluating, to my bool while you're evaluating it. So if you went back up to the top of, with even your first if statement with my bool, and you change it in, to if my bool equals false, you'll notice that it actually skips that part of the code because you're evaluating and assigning at the same time.
Interesting. Interesting. Yeah, I want to play with that. We'll do that as our extra credit at the end of our session today. See if we can get that working. All right, let's start filling in the answers here. So if I were to look at this code, I can see that my first set of conditions, I'm checking to make sure that it is equal to up. So in that case, I'll go ahead and use my comparison operators, and I will see if my pick list equals up, then these results should happen. System debug will tell me the value is up, and my system assert equals, if I want to make it a good test, I say I expect it to be up, and I drop in my variable, and that should result in what I'm hoping is a passing assertion. And then I go on to an else if. Looking here, I see, all right, so this one is trying to test that if it's down. So I'll drop in a comparison that says if it equals down, this is what should happen. And again, for my test here, compare my expected value of down to the actual value of my pick list. And then we get into one that's a little bit less clear. So now we're saying, else if my pick list, we want to see what happens when it's empty. All right, so in that case, we can just say, there we go. If my pick list doesn't have any value in it, we can just use something we're familiar with from workflow, a pair of single quotes with nothing between them. And it's going to evaluate that. And if that's the case, it's going to tell us that the debug output is going to say the pick list is empty. But now we have a slightly different test here. We're not using an assert equals, we're using an assert. And rather like our if conditions, an assert just expects a true or a false output. So we're going to have to look for a string method now that will test if a string is null and return a true or a false. So let's go over to our browser again here. I'm going to look for Apex string methods. And it's a class that I visit often because there are so many string methods and they're all very useful. And if I start looking through here, pretty soon I find a very useful one here that says, aha, look at this. I've got is blank, I've got is empty, not blank, not empty. And there's some subtle differences between these. And if I read into these and try and decode which one I want, I can see that if I use is blank, it's going to return true or false, returns true if the specified string is white space, empty, or null. And is empty is going to only do it for empty or null, so it's not going to count white space. I think I want to use this is empty one. So let's try that one. Here I'm going to drop in, take that out of there. My pick list is empty. Oh, did I get that backwards? I better go back to my documentation here and actually take a closer look at this. When I take a closer look at how this is formatted, I can see that I have to just reference the generic string class first, then the is empty, and then I have to give it an argument, a parameter of the variable that I created. So instead of starting with my pick list, I have to put that in as an argument. And this is one of those differences that you'll encounter when working with methods. Sometimes with strings, like we did with length before, we're just able to say the variable name, then dot notation length, and a pair of empty parentheses, and that'll give us our result. And in other cases, we have to reference the generic class, string class, and then our method, and then we have to give it an argument. And really the best way to figure out when you need to do that is looking at the documentation and seeing how it's done there, and then reverse engineering that for your own needs. Moving along, we've got our failover else here with no condition. And in this one, if we think about what we've already evaluated, well, what happens when it's up, what happens when it's down, what happens when it's empty. So we're sort of left with everything else. And in unit testing, which is kind of what we're doing here, you do want to try and cover with system asserts all the possible outcomes. That way, when your Apex is run, you know that your unit test is really covering you well, and that you have checked all of the possible different outcomes that can exist. Because here we've only defined two text variables, up and down or empty, but it's a string, so it could be anything. So we do want to have a final scenario here that covers that, that last condition. That's why we have an else with no condition. And in this scenario, system debug says the value is neither up nor down nor null. But how the heck do we test that? Well, there's probably a couple different ways we could do that, but the one I'm going to do using my system assert, drop in a couple of parentheses that are needed there, one too many. I'm going to assert that it is none of the previous values. So I'm going to do this by saying my pick list not equal up and use the logical two ampersands to say and my pick list not equal down, and I can use that string is empty, my pick list, to cover the scenario when it's empty. But I do need to reverse that so that I can say it's not empty. So this is an example in a conditional evaluation where we are using multiple comparisons. We've got our first comparison there, and that's going to either evaluate to true or false. And we have our and here, and then another conditional that's going to evaluate to true or false. And whoops. And then we have a third conditional, also with an and, that's going to evaluate to true or false. And this is, of course, when you get into the complex logic of, all right, so do I use ands, do I use ors, when do I use nots? And it can get pretty challenging. Okay, hopefully everyone's back. So we were looking at our multiple conditions here and discussing how it can get complex remembering your ands and ors, but I'm sure everyone has built pretty lengthy criteria filters and has struggled with that, and will be able to put those together when needed. And so we will, let's see, so I'm getting an error message here, so I must have forgotten something. I forgot my semicolon. In fact, the error message even says expecting a semicolon. So there, if I put that in, we'll save that and we'll give this a run here. And it looked like that test passed just fine. Now, if anyone in their work through that came up with any error messages, go ahead and drop them into the chat, and we'll see if we can figure out what happened and try and get things fixed up. It's also a good chance for us to practice a little debugging. But moving along, we're going to look at some other ways that we can use Booleans in conditionals. So there are a lot of methods out there that return Booleans. We were just working with some of those in our previous examples. And now going back to our lesson on collections, we're going to revisit maps. So I set up a map here called metric map. And it's a map that has a key that is a string and a value that is decimals. And if we look at some of the pairs that I populated a key called kilo and set its decimal value to 1,000, and another one called milli, and I set its decimal value to 1/1000. So now that we've got some data to work with, we can take a look at how we might use that in a conditional. So maps have this very useful method called contains key. And when we feed a string to that, it's going to check our map and see if that particular key exists in our map. Now I fed it one called mega. And if we take a look at that previous line, we know that mega is not in there. So this particular method is going to return false. And so that means it's going to skip down here to our else clause. And we're going to actually go ahead and put mega in there. So this is a very useful pattern for working with maps in conditionals. If you know you need to get something out of a map, but you're not sure if it's there, you can use this to first check if it's there. And if it is, oh great, then you get to do what you need. It's already there, and we can go ahead and get mega out of that and get that whatever value is. But if it's not, we go ahead and put it in. This is a pattern that you'll encounter as you start working more with triggers, where you do need to go ahead and sort of verify whether the data you need is there, and if not, take care of that. Otherwise, you're able to move along. And in this case, the first time it goes through, it says it's not there, drops in, and go ahead and puts it in there. And once it's been added in, then we can do a simple test here, since we always want to test our code. And we can use that get method for maps to get mega and verify that it is in fact the decimal value of 1 million. And so now your task is to do the same, but for the key of micro. And so you don't have to remember how many zeros there are. I went ahead and put that into line 106. So I'll give everybody a minute here to try and work through that exercise before we go ahead and fill it in ourselves and talk through it. So hopefully this was a pretty easy one for everyone. Go ahead and uncomment that. And we'll go ahead and pretend that we wanted to get out a value for micro. But in the scenario where that particular key is not already in our map, well, we're going to go ahead and put it in there. So I use the map method called put, and that requires me to provide it both a key, which in this case is a string called micro, and a decimal value, which is 1/1,000,000. And then to make sure that our code worked, I'm going to go ahead and put what I expect it to be, 1/1,000,000th, and then get my key and save this. And we'll go ahead and run our test to see if it worked. And I can see that it did. Hopefully that also worked for you, but if you had any error messages, go ahead and drop them in chat, and we'll use it as a learning moment to see how we debug these kind of things. So our final section here on conditionals is just sort of a review of all of the possible operators that we can work with and what they ultimately evaluate to. So I set up a Boolean of x equals true and another Boolean of y equals false. And I just start doing all sort of comparisons with them. So I have one here of x and y. Both must be true for it to come out to true. And then the next one I have x and not y. Again, the whole expression must evaluate to true. And if we think through this, we can say, well, x is true, y is false, but we reverse that with a not. So that comes out to true, and our whole conditional is therefore going to be true. Then we've got our double pipelines. That's the logical OR. And in this case, x or y. So we have true or false. Well, one true is enough for that to evaluate to true. And then we have another not, but an or. So now we've got false or false. That one's going to come out to false. And then in this case, in our inner parentheses, we have x and y. So we have true and false, which we know evaluates to false. But then we reverse that with a not. And so the whole thing comes out to true. So this conditional would fire. And I'll go ahead and skip over this fix me, but if you want to go ahead and try this with yet a third variable, you can do that and see if you can get these to evaluate to true by adding in another comparison operator and z. But now it's time to move on to our next bit of control flow. And this is one that is really powerful and also something you probably haven't encountered as much as an admin. These are for loops. And the only place we have loops in the declarative interface is when we use visual workflow. And I hardly ever use visual workflow, so whenever I try and use loops in there, I always am running off to the documentation or pretty quickly saying, screw it, I'm going to write this in Apex. And now let's show you how to write those in Apex. So for loops are a way to iterate over a series of data. And that can be something as simple as a list of strings, or it can be a list of records, or lists of records. And so it can get pretty squirrely pretty fast, especially because with Apex there are a lot of different ways to use for loops. We're going to start with one of the simplest ones here. We're just going to work with a list of strings, or actually a set of strings. And we're going to use the set that we created in our map, metric map. And a little extra learning moment here. So in metric map, all maps are composed of keys and values, and we can actually break out those keys or those values into separate collections. So I just break out the set of keys from our metric map. And if you take a look here, you can see I'm setting up a set, and it's a set that contains strings. I'm giving it a name of metric set. And then I go off to my map, and I say, use the key set method to get all of the keys from metric map. And just so you don't have to scroll back up, those are mega, micro, milli, and I think we even added another one in there. So we probably got 4 values in there. And now that we have that set to work with, we're going to start our first for loop here. So the structure of a for loop looks a little similar to the if conditionals in that we say for, and then we have a pair of parentheses. Oops, I keep dragging things around. There we go. We have our parentheses there. But what we put in the parentheses is not a comparison, but it is a way of telling the for loop what types of data we're going to be evaluating. So in our for loop, the first thing I'm saying here is it's going to be evaluating strings. And those strings are going to be called S. And that means that for every string that I feed it, as it loops through, every time it's going to assign a string to a variable S. Where is it getting those strings? That's the second half here. So I use a semicolon to say, get the strings from our set called metric set. So now it's saying,
just a quick note here. So when you use a for loop, there's actually 2 ways to use a for loop, 3 if you really want to be detailed. One is the pattern that Luke described here. And when you do want to run a loop and iterate through a collection, what has to be on the left side always must be an individual record of the collection type. So in this case, our collection is a set of strings. So on the left side, you must define a string. If the collection was a set of integers, on the left side, you must define an integer. You cannot use for integer s in metric set, for example.
Thank you. And yeah, so if I tried to do something else here, like if I said this is a, how about an integer, and try and save that, it tells me an error. Loop variable must be of type string. The reason it knows that must be of type string is because here I'm saying I'm giving this loop a set of strings to work with, and the error message is therefore telling me if you're going to be working with a set of strings, then each time through the loop, it must be of the type string. And so what it's going to do now is grab all of the strings from metric set, and it's going to work through them one by one. And if I go ahead and run our test here, we can see this is on line 142. Let's go over to our logs and see what happens with line 142. And when I filter down to just line 142, now I get a lot of occurrences of that because it keeps looping through it. So it loops through. First time it gets kilo, the first key in there. And then it loops through again, and it gets milli, and again, mega and micro. And it just loops through until it runs out of strings in that set that we gave it. And in this case, all I'm having it do is just do a debug, but we could do any other types of actions in here. If we wanted to, say, get the value for each one, we could say metric, I better do a system debug so we have something to see here. I could say metric map dot get, and then I give it the particular key. And so now when I run it, each time that it has gone through that loop, it changes the value of S, and I'll use 142 again, but really we're interested in 143, so I'm going to click off that filter. Oops, I forgot to highlight a line first. I'll highlight a line there. Now I'll turn it off and it'll drop me right where I want to be. And as we start going into our debug, we can see that here it says the first debug, it returned the key of kilo. The second one, it returned the value from the map. The next debug, it returned milli, and then it returned the value of milli, and so on and so on. So it's a very useful way of stepping through every one of the values in our map. So now your challenge to do the same thing. Instead of with the keys, we're going to set up a for loop that goes through and returns the values, each of the values. Here we did it by using get, but we could also use just a very similar pattern as we did here in this for loop, and that's your instruction. See if you can set it up to just return the decimal values.
Luke, can you look at the chat for a second?
Oh, I think I can. Hopefully I can do it without turning off the... There we go. All right.
I just asked you a question.
Let's leave variable scope out of this for tonight.
Okay.
We've got quite a few other types of loops to get through, and I want to get to all of them tonight. Okay, so let's put out the answer here. Let me get rid of these comments here and start putting this in. All right, so we started here. I provided you a list, and that list is of decimals because we know that was the data type of the values in our metric map, and I gave it a name of metric values, and then I used the map method of values to just return all of the values from our map. So if I want to create a for loop to go through each of those values, I have to start it out by using the correct data type that's in that list. I'm going to give it a variable name of D here and drop in my colon and say, all right, we're working with the list of decimal values called metric values. And then in my system debug, all I need to do is drop that D in there, and now every time it goes through the loop, it's just going to move on to the next one. And if we go ahead and run our test and visit our log, go to line 149, and we can see now it's just spitting out each of the values from our map. So that is the first variety of for loop. But now let's take a look at a second, completely different way of working through a for loop. And in this case, we're going to use a set of data that comes from a SOQL query. So we have a similar pattern where we have to first define the type of data that we're expecting. And in this case, I'm going to be getting user data, and I'm going to call it U, and I get to use my colon again. But now in square brackets, I can go ahead and drop in a SOQL query. Now the SOQL query has to come from a particular table of objects, in this case the user table, and that is what dictates the data type that I'm using for each of the items in the loop. And then from that table, I'm selecting the name field. And so when I fire this, it's going to go ahead and run this query. And we know that from our previous lesson on SQL queries, a query returns a list. In this case, it's a list of usernames. And so as we go through the loop for each of the records returned by that query, we've assigned each one the variable name u, so we can go through in turn and say u, the user record, and then use our dot notation to say, get the name field for that user record. Now what's really critical when you're doing these type of loops is whatever you want to reference in your action section here, you have to have actually pulled that from your from the query. So if I did not include name, if I only included ID, it's going to let me save it and everything looks fine, but as soon as I try and run it, it's going to throw an error. And since I didn't do a system assert, the only way I'll be able to see the error is going into the log here. And I'll scroll through until I see the part that spitting out the errors here, usually towards the bottom, because that's where it ends up breaking out of the code. And it tells me that the row was retrieved via SQL query without the requested field, user.name. So in this case, I could leave the ID in there and just add in the selection of the name field, and then we'll be able to run that, and it'll have that name. It'll be able to go through each time and give me the name for each user. Let's go ahead and run that. And in my logs, I can see it was successful this time. Yay! And if I open that up, this time I'll use my debug only and scroll on down. And I can see it looks like there were 4 users here. That was line 154. There I am. And there's a couple of other users that the developer edition orgs come preloaded with. Now let's see if you can do the same thing, but this time with profiles. So you're going to have to write a query that gets the name of each profile, and then have that output in your system debug statement. All right, let's take a look at how we would construct this. So for our query, we always have to start with our select statement. And if we want to get the names of the profiles, we have to select that field. And it has to come from our profile table. And then in our debug statement, we have to reference that variable name, P, and then use dot notation to get name. So in this case, we're taking a shortcut here by just dropping the query directly into the for loop. But we very well could have predefined this query. We could say a list of profiles, and I'll call it profs. And then I could set up my query here. And cap that off with a semicolon. And instead of using the query directly in there, I could actually just reference that. It's the same exact thing. You'll get the same exact result. The only real difference in doing it this way is that you'll actually have this list to work with for future needs. So if later, for some reason, I wanted to see what the size of that list is, I'd have my list called profs, and I could use the size method. So if you think you might need to do other things with that list of records, it's a good idea to create the list and populate it from the query, and then just reference the list name in your for loop. But if you know you're not going to need that list for anything in the future, you can just go ahead and drop the query right into your for loop. Either way, the actions will be the same, and it really just comes down to whether you need to use that again in the future. All right, so now we've looked at two of them. Our third variation is one that is very useful and powerful and significantly different than the first two we looked at. The first two we looked at were working with lists of data that we already had. We had our query results from the profile, or we had our keys or our values from our metric map. But now we want to do something that is a little more generic. We want to be able to loop through a set number of times. So before, we were totally dependent on how big our list was, how many results came back from our query, or how many key value pairs are in our map. But if we don't have that type of information from the start, we can set up this type of for loop that will go through as many times as we specifically tell it to. So what we're going to do here is we're going to set up a for loop that will run 5 times. And what we have to do to get that to work is we have to define how it knows what those 5 times are. So we start by giving it a starting point, an entry condition. And we define an integer, in this case named I, and I assign it the number 0. And that 0 is, in this case, arbitrary, but it's a very useful convention to start with 0, and you'll see why shortly. But after we've defined where we're starting at 0, then we do a comparison. And in this case, we're saying I less than 5. So it's saying as long as I is less than 5, keep going through this loop. How does I change? Well, that's what we have here in our third part after another semicolon. We use the incrementer, the 2 plus signs, and that instruction says every time you go through this loop, add 1 to I. So I starts out at 0, it goes through the loop, and then it increments I by 1, and I becomes 1. And it keeps going through that loop, adding 1 each time until I is no longer less than 5, and at that point, it stops going through the loop. Let's go ahead and run that and take a look at our debug log.
Just a quick comment on that. Just important to remember and understand that the increment always happens after the loop is run. So you start with 0, it will only increment it after the first time that it runs.
Very true. And the reason that it is particularly useful to start with 0, and we can see here in our debug log that it went through adding 1 each time. And the last one we saw is 4, because as soon as it added 1 to 4, it became 5. And 5 is not less than 5. So that said, all right, the condition no longer applies, so the loop ends. So why did we want to start with 0? Well, if you recall from working with lists, all of our lists are indexed, and the first index is 0. And that means that in a loop, we can step through a list one item at a time and use its index number to get that value out of a list. So I set up that example here where I have a list, and it's a list of strings, and I go ahead and I put 4 strings in there. And just to remind you how we get out our, use our indexes to get items from a list, we put the index number in a pair of square brackets after the list name. So that's telling us get the name at index 0. That would be Dave. So now we're going to slightly modify our previous for loop. Again, we're going to start by setting the integer I equal to 0. But this time, instead of staying exactly 5 times, we're going to use the size of our list to determine how many times it loops through. So we know that there are 4 items in that list. So essentially this is saying I less than 4. But it all depends on the size of the list. And so if you're working with data that might have a variety of sizes, say like a query, this is a way to get it to go through just the right number of times for the number of data that you need to work with. And again, we use our incrementer to bump it up, to bump I up 1 each time. And that allows us to use that index function. But instead of giving it a number, we just say I, because I is going to be each of those numbers in turn. So the first time it goes through, it's going to get the string from the list at index 0, and then index 1, and 2, and 3, until it runs out of items in the list, at which point our condition no longer applies, and so it stops going through. And if we take a look over at our log, we can see that's exactly what it did as it ran through that loop. Value at index 0 is Dave. Then it moves on to index 1, 2, and 3. So this is a very useful combination of lists, incrementers, and indexes to work through a list of data. And because this is such an essential skill to master, I've put in a pretty complex lab exercise here. So I'm going to give you about 5 minutes to start working on this one so that you can really get some practice with this. So the instructions here are that we are going to create a loop, and we're going to predefine how many times we want it to go through. We're going to say we want this to go through 5 times, just like we did in our first loop with the integer entry condition and a set number of times and an incrementer. And then you're going to use that integer value, and you're going to add it to itself. And then we want to, in a debug statement, do the output of that mathematical calculation. And then, in addition, in that debug statement, you're going to have to practice putting together some concatenation to come up with a statement that'll end up in our debug looking like 1 plus 1 equals 2. And so with those instructions, go ahead and give this a go. And one of the particularly twisty challenges of this one is you're going to end up using the plus symbol in a couple of different ways. You're going to use it for concatenation in your debug, and you're going to have to use it as a string so that you can just output it for readable content, and then you're going to have to use good old plus as a mathematical operator. So go ahead and give that a try and see if you can get all of that working, and you can check your debug to see if it comes out the way you wanted it to, or I guess the way I wanted it to. All right, well, despite my attempt at yogic breathing exercises, I still got impatient, and even though it's only been 3 minutes, let's go ahead and see how we do this. Go ahead and take our comments out. All right, so we have to set up a condition that's going to go through 5 times. So we start by defining our entry condition, an integer. Oh, I left out a variable. There we go. Now I have my variable I. I'm going to say I equals 0. And then if I want it to go through 5 times, I have to say I less than 5. And then I have to make sure that I changes each time. So I use my incrementer in there. All right, so now I've set up a loop that's going to go through 5 times. But the action that we want to happen is we want to add I to itself. So there we have our mathematical. But this value, it needs to go somewhere. If we just leave it like that, it's just I plus I, but it's not really something we can reference. So I better create a new integer that I'll call J, And I'll say that j equals I plus I. And I better close that off with a semicolon, otherwise Apex compiler will complain. All right, so now I've got my mathematical operation in there. And now for the complex part, I want to spit this out as a nice readable string into my debug log. So what I'm going to start with is I'm going to say just I. First I want it to return just the number that we're working with. But then I want it to show a plus sign. So if I want to add a string to that, I have to use a plus sign first as a concatenator. And then I have to use another plus sign, but this time I want it to be printed or output in my debug. So I have to wrap that in some single quotes. So now I'm going to have I, which will return as it goes through the loop, 0. And then I concatenate that to a plus symbol. And then I have to use another concatenator, and I again. So now I've got the part that's going to put out for the first loop, 0 plus 0. Now if I want my equals sign to show up in the debug, I have to concatenate that in there in some single quotes. And one more concatenator. Now I can just put simply j in there. So now we've got something that if I got all of those plus signs and single quotes in the right place, something that should output a very friendly result to our debug. So I've saved it, and I'll go ahead and run this. And pop open our logs here. And this should be near the very bottom, and there they are. So all of the long debug string boiled down to just a very simple set of characters here that shows us the mathematical outcome of our looping through the string. Hopefully everyone found that just the right mix of challenging and achievable. Because now we're going to move on to our final example of for loops. Oh, all right, Sajian has a question here. Okay, so I see, Sajian, I see your system debug there, and I'll go ahead and copy that in.
I was just crafting an answer as you started addressing it.
So let's see here. Oops. Clean this up just a little bit. So pretty similar. I like what you did. I like that a lot, in fact. So let's see. I think that would work just fine.
It will. Yeah, it will work.
So instead of actually assigning this to a new integer j, you just did your mathematical calculation right in the system debug. Totally fine to do it that way. As I pointed out earlier when we were looking at using a query in a loop, if we define our query as a list first, we're able to reference it later. But if I just drop the query right into the for loop, I'm not able to reference it. I never gave it a variable name. So that's kind of the difference we're working with here. In Sajian's solution, the output is just directly printed into our debug statement. And in my solution, I assigned it to a variable j. So conceivably, I could do something else with j at a later time. And again, that's just really the developer's choice of what you need your code to do later. And certainly, if you don't need to ever reference j again, you could just skip that line and have something that's a little more simple to read and a little less work for the processor. So thank you.
Look, can you try running it? Adrian says it's not working when he tries.
Oh, really? It sure looked good to me. Let's see what we get here.
Hey, that's a
All right.
work.
All right, so it says it was successful, but let's see the tail of the debug here. Let's skip right past it. Where am I? Got lost. Ah, interesting. So it just printed it twice.
Uh-huh.
Let's see. Why did it do that? All right.
Because
I guess.
Yeah, because I guess the system debug is looking for a string.
I guess it just treats that plus as a concatenator there. I wonder if I don't know if that'll work, but certainly willing to give it a go here. All right, let's see what happens if we try and make it an expression in there.
So here it works. That's not it?
I think, yeah, this is it here, line 189. Huh, interesting. So by putting it into parentheses, we were able to force it to do the calculation. We can see here, this is where I did not have it in parentheses, and it just treated it as a concatenator. And once I put it in parentheses, it treated it as a calculation. I have never tried that before, and I like that. That was great, great contribution. I'm not sure if I can describe why the Apex engine did exactly that, but it is one of those small things that you just learn will work, and then you end up using again and again. Great. Thank you very much for that, Sajian. All right. Our final example here is that you can do loops within loops. And when we do a loop within a loop, we first go through the outer loop. In this case, I set up a list of strings with meters and watts and grams as values. And I set up a pretty simple for loop that just goes through each of those strings and gets them. And then inside of that for loop, I have yet another for loop. And this one is going through our key set from our metric map. And so what's going to happen when we set up for loops within loops is that in the outer loop, it's going to go through U, and it's going to just take that first one out, meter, and then it's going to execute the inner loop. And it's going to keep going through this inner loop until it runs out of keys from our key set. And then it's going to go back to the outer loop, and it's going to get the next one, watt. And it's going to go through that for loop however many times there are items in our key set. And then once it gets through those, it's going to go back out to the outer one and get the third value, gram, and run through all of those on the inside again. And so when we take a look at what actually happened, I'll go back over to my logs here. Oops, skipping around a little bit. So we can, getting some weird scrolling behavior from my browser. If I can gently nudge this into place. All right. So we can see how that behaved. We knew that the first time it went through the outer loop, it grabbed the string meter, and then it went through each of the inner loops. So it got the key, which was kilo, and it appended that to meter, and it said a kilometer is 1,000 meters. And then still in that inner loop, it got the next thing from our metric map, and it set a millimeter is 1/1000th of a meter, and did the same for each of the values in that map And then once it got through all 4 of the values we had in our metric map, it went back to the outer loop, and it grabbed the string what, and then it started building each of the strings in turn for watt, going through kilo, milli, mega, and micro. And then it went to the final one in our outer loop, the grams, and did the same thing for, oh boy, why this wants to keep jumping up there. You know what, I'm going to turn the debug off. Maybe that will cure the...
It does that sometimes. I don't know why.
All right. Now it's a little messier because it's all spread out, but we can see in our debugs that it went through the grams. So you can have many loops within inside of loops and just keep working through them in turn. And so that brings us to the end of our demonstration on for loops. And I know that Ohad had previously suggested that we take a look at scope and variable scope in loops and if conditionals. Ohad, if I'm showing something useful here on the screen, I'll let you go ahead and explain it.
Yeah, go to your example of the double loop that we just reviewed.
Okay.
So this is something that I'm just going to touch very, very briefly on. There's a lot of other implications to it beyond what I'm just going to say right now, but some of it is a little bit more advanced than what we're looking at. But this is already a time to start thinking about something called scope. So when you declare a variable in Apex, really in any other programming, in most other programming languages, it behaves the same. But a variable has a life. It starts its life, obviously, when you declare it. But when does the life of a variable end? So the first thing to know about the scope of variables is that when you start looking at any loops or conditionals, variables that you declared inside a conditional will never live outside of the conditional. So what do I mean by that? Everything that you declared inside a curly bracket will only live until you close that curly bracket that it was in. So a good example for that, exactly, thank you, Luke, you're already going there. If you try to debug U after we already got out of that loop, that for loop, that variable does not exist. But if you move that 2 lines up above the last curly bracket, it will work. And the same with the variable m that we declared for the m loop. If we put the m loop in here, it does not exist because we already closed the curly bracket that started before we declared that variable. So this is something to consider. In general, you're not allowed to recycle variable, meaning if you declare the variable at some point in the code, you cannot declare the variable with the same name again. And of course, the exception to that is if the scope has already ended of the previous variable you declared. So if you declared it inside a for loop, and you're outside of that specific for loop, even if you're in another for loop or outside of any kind of loop, you can then declare it. But again, I said that everything is every variable stays alive until you close that bracket. So if we declare the variable with the name u before that loop, we would not be able to use the variable u for the loop because it was already declared. Or rather, we can use it as long as it's the right data type and everything, but we might change the value of that variable.
Right, so here I defined u before I started in my loop, and as soon as the compiler gets to that, it says, well, you already declared that variable, so you can't reuse it. And in fact, here I have them as completely different types of data, but if I were to correct this to make it a string, I could potentially use it, although it probably wouldn't make sense in this context.
I think you may not be able to declare it. So if you remove the word string, maybe it will work.
Yeah.
From line 200.
Yeah. But I don't even know what
I'm
that
not sure.
would mean. Yeah,
I've never tried that.
So, but that scope variable and the life and death of a variable is why I can keep using I over and over again in each of my for loops. So even though I declared I here, because it only exists in this for loop, I can use it again here as a completely different variable.
Another point that I wanted to make, so that was everything about scope. And if we have another 2 minutes, I just want to make another unrelated comment. So
okay.
One of the things that we're starting to see now is that as Luke writes the code, and the developer console does that actually automatically to a degree, we notice that the compiler automatically does indentation. So you can see that when we start a for loop, you click enter after the curly bracket, the developer console will automatically know to indent the text in a little bit. And it does that automatically. Sometimes if you edit code, you may end up screwing that indentation up. Developer console actually has a cool feature which will auto-indent. So even if you screw up your indentation, you can select your entire text. You want to show that, Luke?
Sure. I'm trying to come up with a nice, let me go ahead
and copy just remove the spacing there. Yeah.
There we go.
So if you select all of your text, I'm sorry?
I just selected all of my text.
And then click Shift and Tab, and it might be different on Mac, I'm not sure. It will automatically auto-indent all of your text. So that is something I use excessively. As you get into programming, you kind of become OCD about these things. And if you're a good programmer, you're really OCD about these things. But my point with this is indentation is very, very important only for us. The computer doesn't care about the indentation. But it makes code much, much, much easier to read and understand. So as you start to develop more complex code, and you have loops, inside ifs, inside another if, inside an else, and you can actually end up with relatively complex conditionals, and these kind of indentation are going to be a saving grace. And that's very, very, at this point, it's kind of the basic structure. You won't find anybody contesting the need for styling. There are still some changes. The only other thing that I would like to add at this point is you notice that here Luke is using comments a lot, right? So we have all these comment lines where he describes what we're doing. But as you write code, make a habit right from the start to always, always, always notate your code. Okay, I'm going into an if statement. Put a note. What is this if statement trying to actually decipher? What is it trying to find out? You're going to a loop. Write a comment why are you looping through this? I'm looping through this list to find a record that matches XYZ. Some description. You will be amazed how much you forget a month, sometimes a week after writing a piece of code. So as you find something you want to add or a bug and you want to fix, a month later, sometimes a year later, these notations are going to be of saving grace. So I just wanted to bring this because this is kind of the building blocks. And if you get used to work like this from the start, it will make you a much better programmer. It will make it a lot easier for others to read your code and for you to read your code as well. So that was my detour. Back to you, Luke.
Very good tip. Very good tip. All right. Well, I think we got through all of our control flow right on time. Thank you very much for signing in tonight and bearing with the only one technical glitch that we had when my phone dropped. But that's an improvement over previous ones, so hopefully we'll have a perfect one next time. And next time is actually going to be in 3 weeks. I'm going off on a vacation, so I'll be getting out the invites for the upcoming one, which will be on September 15th. So keep an eye out for that, and I'm also going to get out the recording for this one, as well as links to the pages we looked at and both this worksheet as well as the answers to this worksheet. So if you didn't happen to get everything or go through all the lab exercises, you'll be able to take a look at that and see how I believed it could be done. And as we saw from Satyan's example, there are alternate ways to solve these. So if you found an alternate way, that's great. That's exactly what programming is about. If you can't solve it one way, solve it another way. So thanks again, everyone, and I will see you all in September.
Have a good night, everybody. Bye-bye.